Hello, my name is Ian Watson, and I'm the Executive Director of the American Membrane Technology Association, fondly referred to as AMTA. This is a continuation of our chats with the pioneers, in which we are trying to record for posterity, or maybe longer, the efforts of the early pioneers in the development of membrane technology. AMTA is a technical association that advocates the use of membrane technology for water treatment, ranging from wastewater reclamation and reuse to seawater desalination. The heart of the technology is the membrane. About 2.5 years ago, the board of directors of AMTA decided that we should make an effort to interview as many of the early pioneers in the development of this technology, not only the membrane, but also the membrane systems that came along with it, as a way of preserving the history of this technology. The roots of this technology are in the United States, and specifically in Southern California. And many of the people who worked in the early days live in and around the San Diego area. AMTA's intent is to post segments of these interviews or chats on our website so that the upcoming generation of engineers and scientists understand what went into the development of this technology and its use throughout the world today. I have great pleasure in having with me today for another in our Pioneer Chat series, Mr. Hob McPherson, Mr. Charlie Hall, and Mr. Peter Darby. And Hob, if you would you give us a little bit about your background in the membrane industry and how you got involved and what you were doing before, if anything?
Sure. I'd rather not go into before. Okay. No, I was in Roswell, New Mexico. I worked for Motorola Communications, and we had a cutback in the Southwest for the first time for Motorola Communications, and I had been by the Roswell, New Mexico test facility, desalting test facility, several times. So I stopped in there to see if they might have an opening. They did, and I went to work there and in the research and development testing of prototype reverse osmosis systems. That's when DuPont, Dow, Philco Ford, Westinghouse, all those companies were competing to get a prototype RO membrane. And we tested tubular, hollow fine fiber, spiral wound, and we tested of all those companies. It was Roga at the time that was the main player at that facility out of San Diego here, the group. And anyway, it was very interesting. When I left there 2 years later, I was running a test program, and we had 22 RO test units of various sizes operating there. We collected the data 3 times a day, each shift, and my job was to coordinate the test program with the manufacturers, and the other part of my job was to help spec the equipment, purchase it from the manufacturers, and then accumulate the data, write about a 50-page report per month to the head of membrane technologies in Washington, D.C., Office of Saline Water, Dr. Chanabasappa, right, who I still remember fondly. He was I think he was one of the real pioneers in this industry. He was really good at what he did, and he was really good at spending government money. and I loved working for him because that was his goal, was to develop the reverse osmosis process and membrane technologies, and he did a great job of it. So after the Roswell test facility, I moved to San Diego and became an employee of, when I took the job, the division here in San Diego was Roga, 30 days later, when I checked in, it was Fluid Systems Division of UOP. So I spent several years, about 8.5 years with UOP. And during that time, was in R&D for a while, then went to technical services about the time the technology really became applicable on a large scale. And we did projects like the Florida, what was it?
Florida Keys?
Florida Keys Aqueduct Authority. That was the first 1 million gallon per day plant in the world, I think. And about that same time, Orange County was developing at 5 million gallons per day. I did some pilot testing for Charlie. I think he was the project manager. And then we started doing a lot of international business, and I got to start up the first major RO, maybe the first RO in the country of Chile, and worked in the Canary Islands with the Spanish government for a project with fluid systems for agricultural applications, so on and so forth. It just, there were 3 of us that did that kind of work, and Fred Miller and Doug Denham, and we would pass one another in the hallway once a month and swap war stories about what part of the world we'd been in. But anyway, there, just Saudi Arabia, I got to commission the palace units. We built palace units for the king and the crown prince of Saudi Arabia. I got sent over there to commission, and at the same time, the Jeddah system was going in. We had a seawater pilot unit, 30,000 gallons per day in the Bahamas, and things were really busy. Anyway, in 1980, I left Fluid Systems and went to Sunnyvale, California, up in Silicon Valley, and went to work for Aqua Media as technical director. I was there for 2 years, and we dealt mainly with the high technology systems in Silicon Valley. And RO was a really big thing at that time. All of the semiconductor companies were putting in RO ahead of the ion exchange systems. And in 1982, the fall of 82, I started Process Scientific, and still have Process Scientific. We'll be 30 years old in November 2nd.
Good.
So
Good.
That's kind of my history.
Good. Charlie, how about you?
My history is maybe a little varied, but I got out of the Navy in '63 and joined General Atomics in their nuclear group building HTGR, the high temperature gas cooled reactors. And I will say, embarrassingly, I sort of had a little too much to drink one day. I sort of got crosswise, and when I rode the motorcycle into the office, I thought I'd better find another job. So I went to personnel. They said, "Hey, there's an opening at Roga." I said, "What's a Roga?" Because I had no idea what it was. And so I went down there and joined Roga. And this was back in '67, I think it was. And Dick Sudak was head of engineering. Rick Gleason was there. Jerry Poole was there, and we were just starting the first commercial developments. The first commercial one, I think, was Texas Instruments that had a 125,000 gallon a day system, cleaning up. Basically, it was set up to reduce the chemical costs of ion exchange regeneration and making computer chips. But what they found out is that all of a sudden, when they put the RO in, their yield went way up because it was taking out a lot of the particulate matter that was getting through the ion exchange, and their chip production went up. I think that was one of the big things that helped the industry grow, because from that point on, if you wanted to be in the chip business, you had to have a membrane system in your water treatment system to get your yields to anything reasonable to compete with Texas Instruments. So I think at that point we could, the development costs were high, the membrane costs were high, but they could afford to do it because the chip value was so high.
Right.
And I think that's one thing that got the financing to get this from a R&D project into a commercial development on it. From then on, we went on, and one of our first projects, commercial ones, was Ocean Reef down in the Florida Keys. It was 350,000 gallons a day, which was a big step forward in size and capacity at that point. It was primitive, I think. We're using steel vessels. We put side entry connections on them and lined them, and we made the manifolds out of steel and lined the manifolds, trying to get the production costs down rather than using stainless steel tubing where we're limited to size and whatnot. And it was interesting in Florida. After we got online, I went over and there was a DuPont facility over on the west coast of Florida, and they had a big sign out. Hey, the world's first 350,000 gallon a day system, was going to be built here. And we were already in production on the other side of the Florida.
That must have been Rotunda.
Yeah, it was Rotunda. And it was, I took a lot of pride in the fact that, hey, we beat them at their game. And from then on, we had some major projects. Water Factory 21 was obviously a big one. And again, that was 5 million gallons a day. And I think at that point in time, that was probably 10 times bigger than any single plant had ever been built. And I think we were blessed the fact that we had a professional customer that really did their job properly and not just fight with the contractors and whatnot. But the Water Factory came online. It was a good job. And I think this lasted many years, and I think it's always been a milestone, I think. And I was very proud of that project itself. And it was one that, we 2,000 volt motors and 900 horsepower, and it was big. And I still remember the controls on it was Westinghouse had their Pneumologic out, which was their first electronic controls, but you still had to hardwire the relays in the back of it. And it comes the day, okay, everything's done, it's built, we got to turn it on, and you go to push that button, and there is you've done everything you can, but there's always that nervousness. When I push this button, what's going to happen? And it was really very good. I stayed with Rogue. I got sold to Gulf Oil, came in, and Gulf Energy, Environmental Systems, Environmental Systems, Fluid Systems. UOP came along. Every 4 years, I'd be at the same desk. The name of the paycheck would change. But I finally left. In '78 and joined Ajax International. Ajax International used to be the exclusive distributor worldwide for the Rogue membrane products, and they got into they were committed to take so much production, and if they didn't sell it, they sort of pushed it over, and next year would take a little bit more, and it got into one of these contractual things where they got in a lawsuit and between UOP and Ajax, and Ajax One was awarded $1 as their compensation. So the lawyers won that fight, but needless to say, Ajax was no longer going to be a distributor for the UOP products. So they got a license from Don Bray to build 4-inch elements, cellulose acetate elements, and we opened up a facility in Scripps Ranch for membrane manufacturing, and moved the Ajax International had a systems business where they built the pumps and the tanks and the hardware. They moved all that down to San Diego, and we stayed there for 2 years, I think. And at that time, Franz Breitling owned Ajax. Ames Cross and Babcock had brought I think a half interest in the company, and ultimately they bought Franz out totally, so they owned the whole project. They had a project in Boabe that they were working on. I think they got a little bit of a cash flow bind and decided to sell Ajax after about 2 years. Cyril Cape came in from England and was going to essentially close the doors on it. And we spent a couple of days, and he said, "Hey, I think I can sell this operation." So we went and proceeded to solicit bids for it, and that ultimately sold the membrane manufacturing operation to DuPont. And DuPont came and moved into San Diego for 10 years. During that time, DuPont did not want anything to do with the hardware business, so we took over as separation engineering. We formed and took over the hardware business from Ajax. And we actually supported DuPont for 10 years. We were their engineering department in San Diego with a staff of 5 people on board for them full time. And they ultimately left in '92, I think, and sold to Tricep. And Tricep moved back up to Santa Barbara. And separation engineering's been hanging in there ever since, and we're doing well.
That's good. That's good.
Pete?
Peter,
Well,
you're not a membrane guy.
Yeah, no, I'm not a membrane guy, but I had a number of one-year jobs after getting out of college, just bopping around, and I ended up in Dana Point with a friend that I had met in Hawaii, and came out and was looking for a job, and just answered an ad in the paper. I had never heard of reverse osmosis, and I looked it up and tried to, get blown up for things, and went down, and it was this was April of '75, and it was really a terrific experience from the very beginning. I remember Hobwell and a few of the other interviews came in. They had been looking for someone, and they couldn't all agree on somebody, so I ended up winning the job because I think Kurt Elwell gave me the thumbs up. Everybody else was kind of sick of interviewing people, but anyway, really, it was a fortuitous time for me. I was only there for a little over a year and a few months, and mechanical type. I was on the component side. Charlie and Jack Luce were the only other mechanical engineers in the place. Not that I was any great engineer, but I definitely looked at things from a mechanical perspective, and so it was at a time when coated steel was showing that this was not something you could build big plants with. The imperfect coatings and the corrosion, and anyway, it's just not appropriate. And Rick Leeson actually had done a lot of great work kind of getting the basics of materials to be used and the like. And they needed someone to follow up on that, and that's kind of where I was. I was left alone, working with a bunch of smart people, zoologists, biologists, chemists, but on the mechanical side, just doing some things that you would kind of cringe at. I remember I was trying to think of the name of one of the guys early on in my training was Doug Denham, who took me up to Orange County, and there was a pilot unit going, and it was a carbon steel. I think it had 48 vessels or something like that. And I'm a detailed person, and Doug was explaining to me how important it was to be certain that the Victaulic clamps were properly fitted. And I checked, and I double-checked, and he was an expert, and I'd like to say I checked every end. I think I did. But I was working with a pro, and we buttoned it all up. I think we had to change out some membranes or something. We lit that thing off, and an end blew out. And I go, okay, and that's kind of where I started to feel that my role with pressure vessels was going to really be, have an extra dimension of needing to be safe, But I was just blown away. I had such great experiences at the beginning. Still not at the pioneering from the standpoint of basic development and basic commercialization, but really when it started to scale up, and now the reliability of components for bigger system became an issue. And then, of course, cost was always an issue. You think about the benefits of using this technology, for example, in semiconductor. It was beautiful because the product was the semiconductors, and the water was just the means to get there. But whenever water, is sold for water, it's like the ultimate commodity. And so it's really hard to find that, that right place to be, how much to spend on capital in order to have, a water cost that's going to fly. But it was for me, it was just fortuitous. I just fell into just the most beautiful little niche, that I enjoyed for many years, from a commercial standpoint, but then, through till now, the people that I met, as you had said earlier in another discussion, Fluid Systems at that time just had a lot of strong people good guys, good leaders, good technical people. And from that place, you know, they just kind of took off on the wind.
That's right.
And every place they lit, something sprung up of value to the, you know, to the development of the industry.
And you
So-
went off and started your own company.
Yes. Yep. Did you want to get into that now, or?
Yes, this is your life history.
Well,
I'll
yeah,
come
I
back
did.
to it later, I can assure you.
Okay, I get uncomfortable when I talk too long in a row, because then I put my foot in my mouth when that happens. I was responsible for development of fiberglass pressure vessels, and knowing that I didn't know what I was talking about, knowing that I really didn't have any idea what kind of standard we were going to meet, and kind of recognizing that people in leadership around me really, you know, looked at it as something, just get it done. And I go, but I needed to have some standard to meet. And I kind of started to find or feel that the ASME code was appropriate. And the longer that I worked at it, the more I knew nobody else had my back. It was like, Pete, you get to call this stuff. No one's telling you can't do it. No one is telling you to do it. Just, you're making these decisions. And as I got further into it, I could feel that management didn't want to invest that kind of money. Their business is trying to promote RO. The vessels were just a means. But for me, kind of being on the cutting edge of making decisions that could be hazardous to people's life, I needed something, and that's where I embraced the code. And as I got into it more and more, there were some other things happening in the world of engineers and being responsible. Some lawsuits over structures that fell down, and engineers were starting to be held responsible personally for their designs in a way that they hadn't ever been before. And all that kind of just came together to say if Fluid Systems did not want to focus on the science of manufacturing composite pressure vessels, then I was going to do it. And so it was an amicable separation, but we were competitors for a while, and then after a while longer, the economics of it all kind of shook out, and there was kind of room for one dominant player and then a few other players around. So that was Code Line.
Right.
So I don't know, was I reasonably linear in that story?
Yes, reasonable.
Reasonable.
Now, Hob, you, Aquamedia was probably one of the, if not the first company to concentrate on the semiconductor market.
Mm-hmm, that's correct.
And I was trying to remember the other day the name of the gentleman who started that company.
It was Jaron Leet.
Jaron Leet, that's
Yeah.
right. That's right. I
Yeah.
couldn't for the life of me remember it.
Yeah, actually, Aquamedia was started from an ion exchange service company. Jaron had himself and a couple of truck drivers in a regeneration facility there in Silicon Valley.
Mm-hmm.
So he provided the rental bottles, the ion exchange rental bottles to the semiconductor companies. And so it gave him a perfect opportunity to get into the business when ROs started
Right.
becoming applicable.
Right.
And he built the company very rapidly. Aquamedia doubled in business, I think, 12 years in a row, and they became the premier company for the semiconductor ultra-pure water equipment.
Yeah, some of the other people, Randy Truby worked there?
Yes,
Who else worked there?
Yeah, I worked for Randy Truby. We'd worked together at Roga Fluid Systems, and then he went up first, and he was vice president of operations, and then Warren Casey landed up there. I took an opportunity up there, and then I moved Steve Kapos up, he worked for me. He ran field service,
Right.
technical service, and who else? I think that was about it as far as people from Roga. But it was an exciting time. You know, there were a lot of developments going on. One of the things that was driving it, the semiconductor chips were becoming more sophisticated, more dense. And each time they made the line width smaller, it took another level of ultra-pure water. And when they dropped below the submicron, to the submicron level, it was a time that was really difficult in the development, because the only way that Intel, for instance, I was working with Intel and AMD and some of those companies, the only way that Intel knew when we were making the water that was at the level of purity to make the chip was when the yield went up, because we didn't have the instruments to measure the level of purity that we had arrived at. Eventually, the instruments caught up.
Yeah.
You know, and I'm referring quite a bit to TOC, total oxidizable carbon. You know, and those kind of the silica at 50 parts per billion, so on and so forth. So
You just couldn't measure it.
no, and a few years later, there were 20 steps involved in making and maintaining ultra-pure water, and it became a significantly sized industry. One of the interesting applications I worked on was with Harris Semiconductors down in Florida, and they were having trouble with their yield, and Jimmy Harn and I went there to troubleshoot the system. Sure enough, they had problems that we were able to identify right away. But they were making the Hellfire missiles, or trying to, and they were getting 1 or 2% yield. And the manager there told me, "Hey, if you can get the yield up, we're gonna do well, because we're selling these chips for the Hellfire missile for $1 million a piece." It's $1 million chip, so we got it. I said, "Well, can we share in that?" You know? Anyway, we solved the problems with their ultra-pure water system, and they got the yield up and became very successful with that chip, and I think it's still being used today.
Yeah, wouldn't be surprised.
Interesting, you know, one of the things I've found most gratifying, I guess, and interesting about being in this industry is all the varied applications that we've all been able to work on and been exposed to, you know. And that's where I've spent most of my time, is in applications development and field operations.
Right.
I mean, that's where my heart is, kind of like Pete's is in the mechanical end, and you know, in the vessels, mine has been in the applications, and things like copper sulfate solution. You know, I had a customer for over 20 years that I worked with to use reverse osmosis, spiral wound reverse osmosis, to take a rinse water off of a copper sulfate or a copper line, where they were dissolving scrap copper by the train car load, and in sulfuric acid, becoming copper sulfate. And then through electrowinning, they would plate that copper sulfate out as copper foil with 5 nines purity, 99.9999. And so they had squeegees, they had a spray system with squeegees, and they collect that water, and they had a high number of these drums running, so they were producing about 380 to 400 gallons a minute or more of copper sulfate rinse water. We were able to take that water and put it through reverse osmosis systems, drive the concentration back up. We ran at better than 90% recovery. The copper sulfate concentrate from the RO went back into the plating bath, mm-hmm. and the water went back into the rinse. Essentially what we did was practically eliminate their municipal water usage by returning reusing both those streams.
Right.
So those applications, I guess indeed we were pioneers, some of us
Right.
in those kind of applications.
Yeah. Charlie, you were talking about Ajax International.
Yes.
And the sale of the membrane side to DuPont.
Yes.
And I can remember we did a couple of jobs in Florida when I was consulting down there, which I still am, I guess. But and DuPont was making significant claims about the effectiveness of the membrane that they couldn't support with data. Now this was, I forget what they called it, but it was a non-cellulosic membrane. Was that something that Ajax had developed?
Ajax was basically all, at that time frame, was all cellulose acetate membranes
okay.
we were making.
Okay.
And, I think DuPont was interested in the spiral wound because, heretofore they had only been using the hollow fiber, and I think there's a lot of chemistry that can be made in the flat sheet that cannot be, let's say, duplicated in the hollow fiber.
Right.
And their chemists were working on development. I think they had trade name of AR-15 or something like that. They had
something like that.
and that was sort of just that was right at the end of that time period, just before they sold it. And I think they were trying to develop that new membrane, and they were making the membrane in Delaware at the time. We would ship it out, and we would be making it into elements. But that sort of just came about at the same time they decided to get out of the membrane business altogether. And I think that technology, I thought, was sold to Tricep.
Yeah, I think it was.
And
I think it was.
but I don't think it ever.
No, I think Tricep tried to make it work and
Yeah.
eventually abandoned it. And
Yeah.
went in the more traditional direction with
It was-
TFC membranes.
Yeah, that was. But it was interesting. I think that the whole Ajax scenario there. Well, I guess it was with DuPont. And DuPont was very good. I think they were very honorable in their business dealings on it. I know when we took over Ajax Systems, the hardware end of it, and they had a inquiry come in for some Ajax membranes. That came to the systems business, and DuPont wanted hey, we want to tell all the OEMs what model it is. So you have to tell us, take the Ajax number and convert it over to the DuPont number and tell us what model they want, so we can tell all our distributors what they can quote on. And I sort of said, hey, it's part of our business is selling the replacement elements for the systems we built. And they got a little heavy. They started to get a little heavy with me and say, Charlie, you're doing a lot of business with us, and I hate to cut you off from that if you don't tell us. And I came back and said, I'll tell you, but I don't think I should have to. And they went back to corporate with it, and they came back and said, hey, this is Charlie's sale. He doesn't have to tell you. And I thought that was really honorable. I mean, they could have strong-armed me, but they chose not to.
Now, was DuPont still licensing their OEMs at that point?
That's really outside some of
That
my.
was always one of their. I think it was both a strength and a weakness.
Yeah.
That for a long time you could only buy B9s
Yeah.
from about 3 people.
Yeah.
And all the other guys, they had to pay full price, which made them non-competitive.
Right. The B9 thing, we weren't really involved in that. We were just involved in the spiral end of it,
Right.
and it was.
And I think they tried that with the spirals as well,
Yeah.
but I don't think it worked for them because they had competition in the spiral
Right,
market.
right.
So,
But it was. I have to give them a lot of kudos for being honorable. I was impressed.
yeah.
And it's.
Did you work on the 12-inch vessel, Peter?
Mm-hmm.
Who came up with that size?
That was Fluid Systems, I
Yeah,
think.
I think it was.
Systems.
I thought it was. My default would be Rick Leeson, but
Yeah.
but I don't really know.
I mean, I think a lot of that, there was, when we had the 8-inch elements, okay? And I think Rick was at Hydronautics at the time, said, hey, we're going to make 8.5-inch elements. Such that, when they buy these, they have to come back to us for the reloads, trying to get that exclusive thing in there. And ultimately it became important, I think, to say, hey, we need a bigger module than the 8-inch. That was the feeling. And Fluid Systems made the first one. We made the test stand for their 12-inch elements. And that was
developed specifically for Yuma?
Yeah, I was going to say, Charlie did the apparatus that wound the 12-inch elements, and we tested them at the Roswell test facility. We rigged up a special test system for them, and that was all in support of Yuma, which I didn't mention before, but a lot of our work at Roswell was in support of the Yuma project. And in fact, the reason the facility was located there was the water under the Pecos River, the subterranean water, is about 20,000 parts per million. So we blended that with the Roswell City water to duplicate the Walton Mohawk Canal in the Yuma project.
Right.
But that's what drove those 12-inch elements was the Yuma project. Just as an aside, one of the interesting problems was, I guess, to carry the load of the Delta P load in the pressure vessel, they used stainless steel product water tubes. And after about 5 or 6 weeks, we started having leaks. Conductivity of the tubes started going up, and we disassembled one of the modules, and we found that we had crevice corrosion beneath the O-rings on the product water tube. Yeah. And that's when, after that, I moved to San Diego, got involved with Pete, and we used to sit and talk about the problems with an RO pressure vessel and how the O-rings are going to cause, if we use stainless steel components and we have an O-ring, we have an issue with, potential issue with crevice corrosion. Right. So all this kind of came together, really. I think a lot of this technology came together at ROGA, at Fluid Systems, and then the people that went through Fluid Systems and left and continued with a lot of the development, like Pete did. And so
I remember something about that now, because the Yuma proposal really, I thought they had done a good job, although I wasn't on the system side, but they had done a really good job defining what they wanted, and it was very modular. And I remember we did do some, Rick's group, which you were part of, had done some work with the column loads, and when the membranes get fouled, the last element in the row is really taking quite a load. So we had resolved at that point that the way that membranes were made up to that point where the product water tube stuck long from the end was no longer going to be the way to go. And the membrane started to kiss not only on the tip of the product water tube, but also on the shell, the face of the ATD, if you will. And so, but that I remember the proposal work for the Yuma proposal really fondly, because it really, everybody was really thinking outside of the box, if you will, but we had been given a really good specification to work with, and it did have a lot of practical impact on the way I think plants are done now, and certainly the way the membrane was constructed. That first development, I was still at Fluid Systems, and it was all part of making a bigger element for that project.
Yeah, because I think most of the elements following for several years, the product tube extended from the face of the membrane, and you had an outside connector.
Right.
And I think everybody now has an inside connector, and it's they match up.
Well, that's on the 8-inch. The 4-inch are almost all the opposite way.
Still, yeah.
Nail ends on it.
Right. What's always surprised me is that having gone down the road of developing a large format membrane, and I guess maybe it was timing, that they never did anything with it. And it's only just recently now we've seen an interest in large format membranes again. Was that a conscious decision on the part of Fluid Systems, or?
I think it's really more, in order to justify that size, the plant has to be X big, and Yuma being a huge, 100 million gallon a day facility, it was big enough. But you start getting into these smaller plants, and I think it's harder to justify the development costs of the membranes and the vessels and all that to get the, if you're pushing high recovery to get the array right and things like that, it's hard to do it. I just think it was a question they didn't have projects large enough
Right.
to pull it off or to justify it.
Yeah, yeah, and I think that some of the early studies that went into they called it the Large Format Membrane Consortium or something.
Yeah.
It really doesn't start to be a benefit until you get over about 30 or 40 MGD.
Yeah.
And then you start getting some significant capital savings. So.
Going back in time, though, it's when we build Ocean Reef, just to put the perspective, okay, these were CA elements, okay, and if we could get 96% rejection out of an element, we thought we'd died and gone to heaven, and getting 500 or 600 gallons a day out of a 4-inch element, we were doing good. And the elements, when they're finished, they just put a tape wrap around the outside. Then we had this rubber brine seal, which was taped on the outside of that, and that was there was no ATDs on either end, none of that. And we were down at Florida Keys, called up and said, hey, we can't keep the product water tubes attached to the vessels; they keep coming out. So I went down there to see what was going on, and sure enough, they kept coming out. And so, and when you took the product water tube off, that stream would go from here to the wall with force. Okay, let's open up the vessel, and I took these elements out, the 4-inch elements, and I could literally go like this around a 4-inch element with my hands, and my fingers would touch. I called the office and said, hey, there's a problem here. The membrane's gone. What do you mean the membrane's gone? There's no membrane. All we had was, we had the sailcloth backing material and whatnot, and the product water tube, and everything else was gone. Apparently they had, turned the system off and left acid running and basically dissolved it.
Dissolve the membrane.
But it was, I called up and said, there's no membrane. What do you mean there's no membrane? There's got to be membrane. Because they were worried about what was the rejection of the membrane.
Totally rejected.
It wasn't there.
I remember one of the nano projects in Florida, and this was long after you guys had left Fluid Systems, but they supplied the membranes. And at that time, they were still working on a non-cellulosic nanomembrane. Filmtech had one, but nobody else had one. So we were still using the old modified CA membranes for Fluid Systems. And this preceded what was about a 3-month-long conversation I had with Jerry Foreman about hydrolysis of membranes.
Yes.
We had a system in there because somehow we managed, and I forget, LA Water Treatment built the plant. We had CA and the low pressure TFC RO membrane in a hybrid array. And there was some concern about the TFC membrane fouling with the organics in the water, because this was a nano plant, so there's a lot of organics in the water. So we had a system where we flushed the second stage with a high pH solution on shutdown. Well, one day one of the operators decided that it worked so well in the second stage to do it on the first stage. So he flushed at pH 12 for about half an hour. And of course, we weren't doing any nanoing at all after that. So we started talking about that, and Jerry sent me some hydrolysis curves, and they're sort of asymptotic. They go from 6 to 7, and it's not too bad. It goes 7 for 8, and you get up to 10, and it's all over in about 2 minutes. I'll never forget that. What a mistake. The development of the membranes really kind of drove the applications, I guess, more than the other way around. You didn't get an application to develop membranes for it.
Right.
And was it the same with the systems business?
I think so. I mean, we almost don't have control of your destiny. We would, if you get an inquiry, you'd sort of try to solve it, without, it wasn't like we're going to go out and we're going to cultivate this market. It's like, hey, we'll sell anything we can get our hands on, to anybody, because, it's more, it's a difficult time when you're just starting off with something that, hey, does this really work? Is this another magnets on pipe stuff, or is this, and it's, there's a lot of charlatans in the water industry, and you had to overcome that, and so we would just respond to anything that we could get our hands on, really.
And it was a good market in those days, but it wasn't a huge market.
Right.
Even in Florida, we were building a lot of plants, but they weren't that large.
Right.
And it's not until the last maybe 15 or so years. That
I think in Florida, a lot of the developers, if you wanted to sell lots in your area, you had to provide water for them.
Oh, absolutely.
And therefore they say, hey, we need a water system.
Yeah.
I think the downside of that, and I use this as an example, that the real estate developer is getting there and he says, I got to put a system in. He's most interested in the lowest capital cost.
Right.
Because he's not going to operate it. He's going to turn it over to the homeowners and he's gone.
Right.
And that sort of forced a design that is threadbare, if you would, because if you say, hey, I'll put in a good system, they'll never buy it. They'll buy it from somebody else that's putting in a cheap system. Right. And I use that as one classic example of when you're talking about the qualities of equipment. If you're selling to a Florida real estate developer, it's one quality. If you're selling it to a nuclear reactor that wants to have the thing bulletproof many ways, you're going to get, they can justify the higher cost because they're going to get 6% return on their investment anyway.
Right. They
don't care what it costs. So it's, it's a difference in quality when you start talking about what machines you're building. And I thought that was always an example I used to show the different quality.
And
both of them are engineered well. They're just they're for different purposes.
That's true. And as I'm sitting on the other side of the fence as a consultant, you see that frequently.
Yeah.
You prepare a specification, or you assist an engineering company in preparing a specification. And when you get the proposals in from the OEM, they've interpreted the specification completely differently.
Yep.
And you could tell just by reading the proposal the type of client these people have had over the years. You can tell the guys have sold only to real estate guys.
Yep.
They buy switches from Woolworths and stuff like that.
Yep. But again, I think both of those projects are engineered well.
Yeah.
They're just engineered for different purposes. If you want to make it cheap, you have to do a lot of work to find that least expensive switch to put in there.
That's right. Bob, you and I worked on an interesting project several years ago, which resulted in you going to Poland.
Yes, sir.
Do you want to tell us a little bit about
5 or 6 weeks. Yeah, that was very interesting application. Nothing, I don't think anything ever became of it, but what it was, or what it is, the coal mines in Poland are discharging a saline water in the 20,000 ppm or 20,000 milligram per liter plus range. And it's low pH mostly, and it's there's suspended solids. Anyway, this water's going into the rivers in Poland in that area and winding up in the Baltic Sea, so it's a huge environmental issue. So our Department of Energy, the EPA, and I think one other division of our government promoted a project there where we were going to aid the Poles in developing technology or applying the reverse osmosis technology to solve that problem. So we built, in fact, in separation engineering shop, we built the equipment in a 40-foot shipping container. We put 2 reverse osmosis, seawater reverse osmosis test units side by side with the pre-treatment equipment, and they were designed so that we could operate them in parallel or in series. And I remember we had to leave a certain amount of space. We had to measure and leave a certain amount of space between the tanks because I had an engineer that was a little bit wide, and so that was one of the problems, trying to pack all the equipment into a 40-foot shipping container. But Charlie pulled it off. He did a great job. Anyway, they sent a couple of PhD engineers over to check it out, to accept the equipment. And by the way, what happened, the Department of Energy, EPA, and some other entities in our government funded about, I think, more than 90% of this project. Some of the little European countries chipped in their token amount of 1% as usual. I'm getting a little political here, but
the European Union funded about 1%, I think.
They funded a small percent of it, but it was mainly the United States. Anyway, the bottom line is that we were able to handle that stream quite well. Carlos and I were over there for about 5 or 6 weeks, and we got some good runs. And we had worked with Hydronautics to get their permission to push the membrane elements, the seawater RO elements, to a higher pressure, to get the recovery up. And anyway, at the end of it, the RO worked really well on there. And I think your connection was with started off with the evaporator supplier.
That's right, yeah.
And I left that part out in the beginning because our mission was, what had happened, the evaporator company had sold the direct-fired submerged direct-fired evaporator to the project. But the concentration wasn't high enough at 20,000 ppm for the evaporator to become economical. So that's when we went ahead of the evaporator with the RO and got the concentration up. I don't remember exactly the concentration level we got to, but it was...
I think it was over 50,000, as I recall.
Oh, we went above 50,000, well above 50,000. And it was an interesting project, and it's too bad that it didn't continue on, but I understand that it was the International Monetary Fund, the World Bank, were looking at funding $50 million or so worth of the full-size plants.
Well, John Tate, who was the guy.
John Tate,
John Tate and had the patent, I think, or had the rights to the patent on the evaporator. Spent a long time trying to solicit interest from a variety of people, including Tom Templey, who at that time was still alive. I think they went, Tom, pulled out some of his IOUs and went to visit some of his friends in the British government, but he never could get it. John, for years, John was persistent, but I think he's finally given up.
Yeah, well, it's kind of frustrating when you see that kind of an application that, that could be very beneficial to the world, to the countries in Europe. But one of the things, if you don't mind, I'd like to mention, you referred to the development of the membrane driving the applications, and I had a thought about the developments other than membrane, other than the mechanical part. Like, for instance, when it was discovered that sodium hexametaphosphate would allow you to push an RO from 50% recovery to 75% recovery or beyond. That was a big development. Yeah. And I got to work with Al Riedinger for a few years, and he's the one that pushed that. And we had a little funny story about that particular development. It happened, I understand, I'm pretty sure it happened at Texas Tech University, where we had one of the first RO systems in, and the Texas Tech area gets their water out of a reservoir up in the Amarillo area. It's very high in calcium carbonate, calcium sulfate. Anyway, Al Riedinger had been thinking that if we could somehow inhibit the precipitation of sparingly soluble salts that was going to be a big development in reverse osmosis. He was convinced. He'd been talking to Dr. Chanabasappa about it. Dr. Chanabasappa wouldn't let him try it, wouldn't fund or let him try it on. So anyway, I understand that Al Riedinger called somebody and said, he was out in that area. He was doing the pilot work. And so he's running the RO, and the RO performance was crashing, just in a few days. And he called in and said, if Dr. Chanabasappa tries to get a hold of me, I'm not going to answer his calls. So keep him off my back for a couple of days. And Al started injecting a little bit of sodium hexametaphosphate, and the performance came back. The calcium carbonate resolved. So that was a huge development in reverse osmosis technology.
That was, and one of when the last group, Don Walker was talking about when he started his chemical business.
Mm-hmm.
We had a problem in Florida with sodium hexametaphosphate. Everybody bought it from the same distributor.
Mm-hmm.
And one weekend, about 8 plants crashed, all at the same time. We traced it back to sodium hex. And there was a new product on the market then which came from Flocon, which was Pfizer.
Pfizer, yeah.
And it was a very simple scale inhibitor. So everybody started using that, and that was that I think triggered the start of the whole RO chemical inhibitor and cleaner business. But we all switched at the same. I was at Sanibel then still, and we all switched at the same time.
One of the things, a little slightly different than that, but when we first made CA membrane, the CA was cast on a drum, and it was laid physically on sailcloth. It was not cast on sailcloth. It was laid on sailcloth, and we were making, and that seemed to work. All of a sudden, we got a different supply of sailcloth because it's expensive component, and put it in. All of a sudden, hey, rejection changed a lot. What's causing all this? And it turns out that there was the sizing material they put in the sailcloth would help plug up some of the larger holes in the membrane, and rejection would go up. And it came, this sizing material. We ended up getting that sizing material as a liquid or quasi-liquid called elephant discharge. You pick out the one you want. And we would end up, when a membrane had a problem, we could re-inject that and bring the performance back up again.
We used to call it snot.
Well, there's other ones too.
Pete, when you left Advanced Structures, you became a member of the board of directors of an energy recovery company.
Yes. Yeah.
About the time that energy recovery was becoming very important in the seawater game. You want to tell us a little bit about why you took that assignment, and did you have fun doing it?
Yeah, Gigi called and told me about the company.
That's GGPK.
Yes, sorry, GGPK. And they were looking for some investment, and I had a long string of not so successful investments in small businesses, and I said I'm not going to invest in anything that I don't have any hand in at all. I just have not done well at all. And so he said, okay. And then maybe a couple of months later, maybe a month, he called back and said, we want you to be on the board. We're not looking for an investment. And so I came on at his invitation. There was some turmoil in the ownership, the inventor, and a whole bunch of things going on. And I'm not really sure what skill set they thought they were getting with me, but they asked me, and it was interesting. And it was definitely something I liked in the sense of being very kind of a pure play, if you will, a real, here's the problem, here's the solution. It's very straightforward, and it couldn't get simpler. One of those things that kind of make you scratch your head and wonder, how does that really work? And And so most of the investors were Norwegians, and they had kind of followed the Norwegian inventor a long way, and they were not happy with where things were going, and there were a lot of things to resolve, but everybody understood the potential for the device, but they were still stumbling over themselves. And so I came in as part of getting over the moving out of the original inventor as part of the group, and we just struggled for a number of years. The investors, the Norwegian investors, were really good to keep putting money in when there was nothing much but a lot of almost successes. But then come 2005 or so, finally worked through, I started in December of 2000, but by 2005 they had really gotten to where they knew what they were building, and they made it right the first time. And then they really started to take off and do well, and then lo and behold, they end up going public, in a year when there were no IPOs except for Visa, the credit card, and here's ERI as an IPO. It really is a testament, first, I guess, to the investors, the Norwegian investors that just stuck through it, like you wouldn't believe. And then also Gigi in particular, just a tireless guy. He really had a vision for it, and he made it happen. And so it was thoroughly enjoyable. I came off the board when they went public, but it was a wonderful experience. One of the few investor experiences that actually came out.
So now you're no
Good.
longer on the board. As an investor, I can't sue you.
That's right.
Oh,
I know nothing. And whatever I know, I can't tell you. No.
So I'm going to ask you all the same question, or two questions actually. Is looking back on your career in the industry, if you were faced with that career decision today at the age you entered the industry, would you do the same thing? And the second question is, what single individual has had the most influence on you during that time? Bob?
Wow. The second one is tough.
Yeah.
Really tough. I don't know that I can answer the second. The first one is yes. I tell people when I'm talking about what I do, what I've done as a career, I can freely tell them that there's never been a day, I don't think there's ever been a day that I've worked in this industry that I was bored. There's always a challenge, always a new thing, and always another application. So that's been exciting. The business side, has been a little dull and not so exciting at times. But as far as the second question, that I don't think I can answer that, because I think of people like Dr. Chanabasapa, Al Riedinger, Jack Luce, I've got two guys sitting here beside me that have had a lot of influence on me. Some good, some bad. No, I'm joking. But, it's just the interesting people, and it seems like that at Fluid Systems there was a nucleus, there was a small group of very talented people. And I remember when I went to work for the technical services department, and now Jack Luce is my big boss, and I flew to Florida with him to start up the Florida Keys Aqueduct system. And I was a little nervous being with the big boss, We got on the airplane, sat together on a plane, and Jack and I started talking, and I found out he's a good old boy farmer kid from back in the Midwest, and he and I had a lot in common. I grew up in Texas in a small ranch community. And Jack wound up telling me on the way down there about his first real engineering management job in the industry for General Dynamics was to build a chicken gun. to shoot a 9-pound bird into the windshield of an aircraft. And he said, here I was a green farm kid, young engineer, fresh out of college, lived in California, and all this exciting stuff going on, and I'd done a good job. And the boss called me in and said, Jack, I'm going to give you a project. I want you to build a chicken gun. He said, what in the hell is a chicken gun? But he pulled it off,
Yep. Yep.
He went out, he said, I just had to go do it. So I went out and developed it. But, that's the kind of character that I found in the industry. And I don't know if the industry attracted those kind of people, or this technology, or if those kind of people made the industry that interesting, Anyway, I hope I answered your question.
Yeah, you did. Charlie?
As I said, I started here in '67 in this industry, and here it is 12, and I'm still going in it. And I would do it over again. And it's been a fun ride, and I'm still riding. But it's interesting that when he first came in, I first heard about this stuff. I took the Roga class that they were teaching, trying to get people to doing this, and I said, hey, this is better than sliced bread. We're going to all get rich instantaneously. Well, that didn't quite come to pass, but it was really, it's really good. And I think the thing I enjoy most is, for me, one of my objectives is trying to push the development of membranes into new applications. I mean, San Diego tap water for a rinse line, forget it. I mean, home drinking water, even seawater is getting to be, standard stuff nowadays.
That's right.
And I want to push, I'm trying to push things. Hey, get into the chemical industry. One problem with water is it's worth $1.50 1,000 gallons or something like that. And if you make a 10% increase in the cost of water, you have a major impact on its utility. But you start looking at some of these chemical applications where things were $1 a gallon. Hey, that's $1,000 1,000 gallons. You can put a lot more equipment, and you can afford to do things. And a lot of times you can get, hey, membranes only last 6 months. Great. It's so profitable we can afford to do it. I mean, there's a lot of stuff out there that I don't think the surface has really been scratched very much.
Right.
And for me, I think that's the thing I enjoy the most, and I still enjoy going to work today. But
That's great.
as far as I come back with hobby, I think it's the same thing on in a particular individual. I think it's more of the collection of people that were all enthusiastically involved.
Right.
And it wasn't. Hey, I retired 2 years ago, but I'm still here getting a check. No, it's everybody had enthusiasm and they wanted to do it, and everybody contributed in their own way to success of the industry. And I think I don't think I can put a name on a single individual, because I think it's just so widespread that everybody was so enthusiastic about it.
Right.
That's my call.
Peter?
Yeah, that's good. I won't be able to come up with anyone in particular other than a couple of events, and I'm going to need your help with the name of the young engineer that worked for you for a while, and he's down in the...
Dean Bedford.
Dean Bedford. So anyway, first of all, I really fell into just a terrific place, Fluid Systems, at a great time. I wasn't there that long, but I've been embraced like I was one of the guys going back there.
And you made big contributions.
Well, I don't know. I
significant.
think I just fell into a great place. And then, but I appreciate that. And then just a wonderful niche, a niche. People didn't think you could make a business out of this. But going further, there were a couple of events. One of them was very early on. I think it was 1977, early in the year. So the business was brand new. And I had done a lot of development work to make certain that the vessels, these 4-inch vessels that we made, would meet the ASME code in terms of cycle and burst performance. And did all this stuff and was selling a few vessels to friends, just a little here and there. And Millipore was coming out with some new line of machines bigger than their little lab equipment, and they needed some 4-inch vessels. And a guy named Ari Golan, who was fairly high up in the organization, came out, and I'm in a garage, and it was long, skinny place where we had to walk the vessels out to turn them around to bring them back in to, do some work on them. And he came out and he said, we don't normally work with one-man companies and, whatever. But he said, I see what you've done and we're going to go with you. And I just remember from that point when Millipore made a decision to use our product, everybody else then felt free to use it. Okay, if it's good enough for Millipore, done. You don't have to listen to the long version of Pete's, clamoring about the ASME code. And then the second one was Dean Bedford, because I had been working to influence specification writers to put their foot down and to embrace the ASME code. In fact, I visited with you some, and I can't remember how many times I talked to Dick Sudak about it, and everybody was for it, but there was really a unwritten or written rule of consulting engineers that you will not single source a product. And we were the only ones with it. Huh?
In many places, it's the law.
Yeah. And so, anyway, Dean Bedford was the first guy on some job in Florida, said, this is the right thing to do, and I'm doing it.
Yeah.
And he just did it. And then from then, everybody fell into line. But I really appreciate those people that are the first to give it a try, that they not only analyze it, but they say, this is the right thing, we're going to do it. And those are the two guys that come to my mind when I think about, I didn't work with them, but, they made one decision and, I benefited from it. So
I could probably sit here for another hour or so talking to you guys, but we've got to move on. So
Okay.
Thanks very much. I really appreciate you coming. And
It was a lot of fun.
yeah.
it is.
And we're going to keep talking after we leave.
Yes, absolutely. And we'll talk tonight.
Yeah, Ian, thanks a lot. Really
Thanks very
appreciate
much.
you doing it. And I know
Take care.
we do. Yeah, you too.
Thank you, Ian.